Welcome to my video on quadrilaterals. So we are going to be looking at different types of quadrilateral and what makes a quadrilateral. So a quadrilateral is any four-sided figure that does not have a more specific name. Quadrilaterals are the broadest category and contain all other four-sided figures. Specific names are given to quadrilaterals that can be classified by sides and angles. So let me get this. Whoops. Okay. Sides and angles. Okay, so what is a parallelogram? A parallelogram is a quadrilateral because it has four sides. And if you look, opposite sides are parallel. So this is parallel to this, and this is parallel to this. So they're parallel and congruent. And opposite angles are also congruent. So if you look here, this is congruent to this, and this is congruent to that. That's what opposite angles are congruent. So then, oftentimes on quadrilaterals, you'll see markings to show what angles and what sides are congruent. So this side is congruent to this side. And then I'm going to use a different marking here because it's a different size. So this side is congruent to this side. And then, of course, you can do the same thing with the angles. So I'm going to do 1/2 circle there, and that's congruent to that because we said opposite angles are congruent. And then this one, I'm going to use a double, is congruent to this one. Okay, so if you look for the same symbols, that tells you they're congruent. So congruent, 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 congruent. Okay, turn to page 2. What is a rectangle? Okay, so a rectangle is a parallelogram and here's why it's a parallelogram. Opposite sides are parallel and congruent. And remember, a parallelogram has two sets of parallel sides, meaning this is one set that's parallel. So this is parallel to this, that's one set, and this is parallel to this, there's the second set. Now here's what makes it a rectangle. It has 4 right angles, which measure 90 degrees. Okay, so I'm going to go ahead and draw in my right angles, and I'm just drawing a box in here, and it's very difficult for me to draw a nice square box, but do the best you can there. And then I'm going to do my markings. So this side is congruent to this side, and this side is congruent to this side. Now, it says diagonals are congruent and bisect each other. So this is where you're going to need a ruler. So I will give you a second to get a ruler. Okay, and we are going to connect the opposite angles. Okay, and we're going to create a diagonal which bisects each other. So I'm going to grab my line tool here, and you're going to use your ruler, and you're going to line up this with this, so draw on that line. And then you're going to line up this and this angle. And now you can see that the diagonals are congruent and they bisect each other. Okay, moving on to a rhombus. And leave that ruler out because we will need it again. So what is a rhombus? Well, a rhombus is also a parallelogram. And that's because, well, I have this a little out of order, but let's go with this. This is what makes it a rhombus. All sides are congruent. So let's make the markings. One, this side is congruent, and that side is congruent. And notice they all have the same markings, so they're all congruent. Now, opposite sides are congruent. Oh, actually, I always like to say parallel first. Parallel and congruent, sorry. Opposite sides are parallel and congruent. It just sounds better to me to put parallel first. I don't know why. Okay. And then opposite angles are congruent. So meaning, and let's do the markings, this angle is congruent to that angle. Those are opposite angles. And then this is a different angle because this is obtuse. That angle is congruent to that angle. And just a quick review, these are acute because they're less than 90. This is obtuse because it's greater than 90. Okay, now we're going to need our ruler again, and we're going to see if we can figure out what goes in this blank. So let's draw our diagonals. So connect those two angles and connect these two angles. Okay, now diagonals, and I think you figured this one out, bisect each other. What kind of angles? They intersect at what kind of angles? Hopefully you were thinking right angles because draw the little box in. Okay. Oops. And folks, I don't want to erase here, but make your boxes look like squares. It's very difficult for me to do on the computer here, but make them look like square boxes. So they intersect at right angles. Okay, moving right along. It says, what is a square? Okay, you probably guessed it by now. This is the third type of parallelogram. So far, we've had rectangle, we've had rhombus, and now square is the third parallelogram. So it's a parallelogram, and it's actually a rectangle. And if you look back at the definition of a rectangle has 90-degree angles. Well, so does a square. So that makes square a rectangle. So let's draw in our markings. So there's our right angles. Okay, and because it has 4 right angles, that means it's a rectangle. Now this is what makes it a square. It has 4 congruent sides. So make your markings and then write rhombus with 4 right angles. And all sides are congruent. So yes, this is also a rhombus because it has 4 congruent sides. But remember, a rhombus says nothing about right angles. So that's why the rhombus up here is not a square, but this square is a rhombus. Okay, and that's where things get a little confusing. Okay, opposite sides are parallel, meaning this is parallel to this, and this is parallel to this. Those are opposite sides. Okay, it has 4 right angles, which measure 90 degrees. Diagonals are perpendicular. And remember, perpendicular is when 2 lines meet to form a 90-degree angle. They're the same length, and they bisect each other. So grab your ruler again. Now grab my line tool. And we're going to connect the opposite angles like this. Okay? And they're perpendicular, and they form a right angle. So look, when two lines intersect and form a right angle, that's called perpendicular. So you can draw square in. Okay, so each of these are right angles here. Okay, we have one last shape to discuss, and that's a trapezoid. Okay, a trapezoid is a quadrilateral with exactly one pair of parallel sides. So remember, parallelogram has two, trapezoid has one pair of parallel sides. Not always, but could have one pair of opposite sides congruent. And a trapezoid with congruent non-parallel sides is called isosceles. So these are non-parallel sides right here, and they're congruent. So we call this an isosceles trapezoid. So let's, trying to think where we can put it. See if you can squeeze it in here, or see if you can write it inside the shape. Wherever you can fit isosceles, I just want you to know that this is isosceles trapezoid. And this one is another type of trapezoid, and we call this a right angle trapezoid because it has two right angles. So right angle trapezoid. Okay, now we're going to look at this chart, and we're going to fill this out together using all the characteristics that we've just learned about. Okay, so I'm going to read the characteristic, give you a second to think about it, and then we're going to mark it. So, parallelogram. So this picture right here, only one pair of parallel sides. No. Two pairs of parallel sides. Yes. All sides congruent. Not in this one, no. Opposite sides are congruent. Yes, these are congruent, these are congruent. All angles are right angles. No. Opposite angles are congruent. Yes. Okay, now we have a rectangle. Only one pair of parallel sides? No, because that's a trapezoid. Two pairs of parallel sides? Yes, because it's a type of parallelogram. All sides congruent in a rectangle? No. All right angles? Yes. Opposite angles are congruent? Yes. Oh, and opposite sides are congruent? Yes. Because look, this is a parallelogram, so it's got to have all the markings of a parallelogram. And what makes this a rectangle? The right angles. So that's why this one has one more check than a parallelogram. Okay, a square. One pair? No. Two pair? Yes. All sides congruent? Yes. Opposite sides are congruent? Yes, because it's a parallelogram. All right angles? Yes, which makes this also a rectangle. And opposite angles are congruent? Yes, so that has every single one except for one pair of parallel sides. Now, a rhombus. Only one pair of parallel sides? No. Two pairs of parallel sides? Yes, because it's a parallelogram. All sides are congruent? Yes. Opposite sides are congruent? Yes, because it's a parallelogram. All right angles? No. Opposite angles are congruent? Yes. And the last one is a trapezoid. Because it's a parallel, not a parallelogram, it's not going to have any of these markings. So the only one it's going to have is one pair of parallel sides. Okay. Now we've got one last page and we're going to complete the quadrilateral chart. So I need to pull up a chart to make this a little bit easier for you to fill out because it's sideways on the note. So turn to page 4. And what are we learning about? What are these groups of shapes called? Quadrilaterals. And what was the one shape that we learned about that is not connected to the others? It's kind of by himself. Yes, that's a trapezoid because it has one pair of only one set of parallel sides. So that's a trapezoid. So he's by himself. Now, look here. What do we call the big group of quadrilaterals? The parallelogram. And remember, there's 3 types of parallelograms. And do you remember the secret one? The secret one is the square, because the square is all of the other shapes under the parallelogram category. It's a parallelogram, it's also a rhombus, and it's also a rectangle. So these are the 3 types of parallelograms, but a square is a rectangle, and a square is a rhombus. And so they all connect back to parallelogram. That concludes our notes on quadrilaterals. I hope you have a great day.